Lesson on static charges. Electric charge. You're probably already familiar with the different types of charges, that is, the positive charges and negative charges, and the particles that carry these charges, the protons being positively charged, electrons being negatively charged, and not to forget neutrons, which are neutrally charged. The protons and electrons carry what's called the fundamental charge, which we'll see in another video. So how can one identify the type of overall charge of an object? Well, that's by comparing the amounts of positive and negative charges. If we look at this metal sphere on the left, we see it has 2 negative charges and 2 positive charges, and thus its overall charge is neutral. The sphere in the middle has 4 negative charges and 2 positive, thus making it having an overall charge of negative. And the last sphere here on the right, which has 2 positive charges and 1 negative charge, we would say is positively charged. In class, you'll be challenged to sketch the charge distribution of an object and to determine whether it's neutral, negative, or positively charged. Conductors and insulators. Objects that are conductors have the ability to transfer charges due to having free electrons, unlike insulators, which do not allow for transfer of charge due to their electrons being tightly bound to their nuclei. Even when you put more electrons on an insulator, it still holds on to them and will not allow them to transfer to other objects. Let's take a look and see if you can identify which type of object below is a conductor or insulator. Copper wire, is it a conductor or insulator? Copper wire is a great conductor of electricity. Soccer ball, conductor or insulator? Well, soccer ball, due to its leather or synthetic material, is an insulator. Metal sphere, conductor or insulator? Well, all metals are great conductors of electricity due to their free electrons. Comb, plastic comb, is it a conductor or insulator? Well, plastic comb is a great insulator. Pencil, conductor or insulator? Well, pencil is actually a great conductor due to the graphite lead being a good conductor of electricity. Polarization of charge. This is simply the separation of positive and negative charges of an object due to the presence of charge. Let's look at 2 examples. Here in example 1, we see a metal sphere on an insulating stand, and this sphere is neutral. We can tell because there's 2 positive charges and 2 negative charges. But what happens if I bring a charged object near it? Here I brought a negative balloon near this metal sphere, and now you can see that the negative charges on the sphere have moved away from the negative charges in the balloon. We would now say that the metal sphere is polarized. Notice it's still neutral, it has 2 positives and 2 negatives, but these charges are separated. So this side is slightly more positive and this side is slightly more negative. Let's take a look at a second example using Scotch tape and bits of paper. Here I bring a charged piece of tape near bits of neutral paper, and let's see what happens. If you notice, the papers are attracted to the tape. And let's see if we can get a piece of paper to stand up. Oh, right there is good. So here we see in this example that we have a charged piece of tape. Let's say that that piece of tape is negatively charged. That is, it has more negative charges than positives. Well, the paper is neutral, but yet if I get a piece of paper to stand up, its positive and negative charges must have been separated. That is, the negative charges in the paper see the negative charges in the tape and go downward and are repelled by that. The piece of paper is still neutral, but the top is slightly more positive and the bottom is slightly more negative. We would say that these bits of paper right here are polarized due to the charged piece of tape. In the next few slides, you'll see examples of the different methods of charging. Charging by friction, contact, and induction. It's important to note that the conservation of charge is obeyed in these examples. That is, the total amount of charge before and after charging is conserved or the same. Charge can neither be created nor destroyed. Charge is simply transferred from one object to another. Let's see these 3 different methods of charging. Now let's take a look at the different methods of charging. First method of charging is charging by friction. This is simply the transfer of negative charges from one object to another by friction. Here's an example I'm sure you've done as a kid. You have a neutral balloon here with 3 positives and 3 negatives. You have yourself here, or there's me, and you have a neutral wall with the same amount of positive and negative charges. Let's see what happens when I rub the balloon on my hair. Well, now I can see that the balloon is slightly more negative. It's picked up negative charges. Well, where did it get those charges? Well, off my hair. I know what's left of my hair. But now my hair would be slightly more positive as I lost negative charges to the balloon. We would now say that the balloon is charged by friction. What do you think will happen if we bring this negatively charged balloon near the wall? If you said the balloon sticks to the wall, then you're right. But why does the balloon stick to the wall? Well, the balloon is actually attracted to the wall, meaning the negative charges in the balloon repel the negative charges in the wall right where the balloon is at near the wall. Thus, the wall right here is slightly more positive, and these positives are attracting the negative charges in the balloon to it. So we would say that the wall in this area is polarized. You should also note that the balloon would also be polarized, and I'll leave that for you to sketch what the balloon would look like being polarized in this state. Lastly, remember that charge is conserved. That is, the total number of charges that were on my hair and on the balloon to begin with are still the same amount. It's just that my hair has fewer negatively charges because now they're on the balloon. Charging by contact. This is the transfer of negative charges by direct contact between conductors. The object you're charging becomes similarly charged as the source of charge. In this example, you see me take a negatively charged plate and bring it in contact with a neutral metal sphere, thus charging that metal sphere also negatively. So here you see I start with a negatively charged plate and a neutrally charged metal sphere. I then bring that plate in contact with the metal sphere. Here now you can see that some negative charges were transferred from the plate to the sphere. Before we had 5 negative charges, now we only have 3, and those other 2 charges are now present on the metal sphere, thus making the metal sphere also negatively charged as the plate. Lastly, you should note that charge is conserved. The plate lost negative charges, but they simply were put onto the metal sphere. The total number of charges is still the same after the charging process as was before. Thank you for watching, and see you in class.